A uniformly charged solid sphere of radius r has potential V0 measured with respect to infinity on its surface. For this sphere, the equipotential surfaces with potentials 3V0 by 2, 5V0 by 4, 3V0 by 4 and V0 by 4 have radius R1, R2, R3 and R4 respectively. Then we are to select from the four options. Now the case mentioned over here is the solid sphere which is uniformly charged, and for uniformly charged solid sphere the equipotential surface is the family of spheres, concentric spheres to be precise. Unlike spherical shell, electric potential inside the solid sphere is not going to be equal to 0. In fact, it will be, not going to remain constant. It is going to have some value. So potential at any point within the solid sphere now this can be given by formula V is equal to KQ 3R square minus small r square by 2r cube. This is the expression for the potential at any point lying at distance small r from the center. So if this is a sphere, then potential at the point which is lying at distance r from the center is given by this expression. Capital R indicates the radius of sphere. Now we want to calculate that what will be the various radius as per the things given to us. So for that we can proceed like this. First information that is available to us, that potential on surface is equal to V0. So given V0 equal to KQ by R. We also know that potential at any point is KQ 3R square minus small r square divided by 2r cube. So we will write 2r square over here and keep r over here. That gives potential at any point as V0, which is KQ by R, 3r square by 2r square, or in fact we will keep 2 over here. So 3r square by r square, that will be equal to 3 minus r square by capital R square. So now this becomes the expression for potential at any point within the sphere in terms of the expression of potential on the surface. First case given to us, when V is equal to 3V0 by 2. Now in this case it is specified that radius of the equipotential surface is R1, so we will write R is equal to R1. That gives V is equal to V0 by 2, 3 minus, in fact over here also we will replace it as 3V0 by 2 is equal to V0 by 2, 3 minus R1 square by R square, we see cancellation of V0, we see cancellation of 2. That gives 3 is equal to 3 minus R1 square by R square. This 3 will get cancelled out, simply giving us R1 is equal to 0. So we are talking about the point which is exactly at the center. So R1 is equal to 0, that is the first conclusion. Second conclusion can be drawn under the condition when V is equal to 5V0 by 4, R is equal to R2. So 5V0 by 4 is equal to V0 3 minus R2 square by R square. So this cancellation gives us 5 by 2 is equal to 3 minus R2 square by R square. This on simplification will give us R2 is equal to R by root 2. So that is equal to 0.7 into R. In the third part, when V is equal to 3V0 by 4, then radius of the equipotential surface, it is R3. So that gives us 3V0 by 4 is equal to V0 by 2, 3 minus R3 square by R square. Again necessary cancellation lead us to R3 is equal to whole root of 3 by 2 into R, simplified as 1.2 R. We see that R1 was 0, R2 is 0.7 R, R3 is 1.2 R. So radiuses are increasing in the order when V equal to V0 by 4, R equal to R4. So V0 by 4 is equal to V0 by 2, 3 minus R4 square by R square. So this lead us to R4 is equal to root of 5 by 2R, simplified as 1.6R. Now we can see certain fact. R1 and R2. R1 was 0, R2 was less than R. So these are the points lying within the sphere. R3 and R4 are greater than R. So these are the points lying outside the sphere, or these equipotential surfaces are lying outside the sphere. We can also see R4 is greater than R3 is greater than R2 is greater than R1. Now on that basis, let us try to see and select the option. First option says R1 is not equal to 0, so it will be ruled out from this point itself. Second option says R1 is equal to 0 and R2 is lesser than R4 minus R3. R4 was 1.6R and R3 is 1.2R. 1.6R minus 1.2R, that is 0.4R, and R2 is 0.7R. 0.7R is greater than 0.4R, so even this option is ruled out. Twice R greater than R4. R4 is equal to 1.6R. 1.6R divided by 2, that will be 0.8R. R cannot be less than 0.8R, so even this option is ruled out. Fourth option, R1 is equal to 0 and R2 is greater than R4 minus R3. Obviously R4 minus R3 is 0.4R and R2 is 0.7R. So this is the satisfying option. Correct option is option D in this case.